The question says we should find the square of y over the x squared if 2 open bracket x cubed minus 1 close bracket y plus y cubed minus 7x squared y equals 0. Right. This question is obviously taken from differential calculus. What it means is that we've been asked to differentiate this equation of calculus twice. All right. And it's also said that at point x is 1, y is minus this. All right. When dy dx is equal to 0. All of these were added during the question on the interface. All right. So what are we going to do with this expression? So you have to be very attentive. All right. This question is going to be very interesting. So our solution, we have 2 open bracket x cubed minus y, all right, all plus y cubed, all minus 7x y equals 0. Now, look at the question very well. This term contains y, isn't it? And then this also contains, there are 3 y's here, so y cubed. Then the last term also contains y. So what are we going to do with this? To be able to make it a very superlative equation for us. So we could factorize y out. So y, bring y out. And then we have, and open the bracket, you have 2x cubed minus 2. All right. So there's going to be a major bracket here. Then we have plus y squared minus 7x squared. The result is equal to 0. All right. So if we divide both sides of the equation by y, all right. So this y we cancel this, and then we are left with this. Of course, 0 divided by y is going to be 0. So we have 2x cubed minus 2, and then plus y squared, 7x squared is equal to this. Now we can make y the subject of the formula by transferring all the other terms to the other side. Or as it is like this, you can go on with differentiation. So we have d dx of this expression x cubed minus 2. You can rearrange. All right, we have minus 7x squared plus y squared, all right, is equal to 0. This is, we're trying to take the first derivative of this expression, and this is what it gives. All right. Now what we're going to do is differentiating now. We're going to have, all right, let's cut it from this side. So if we differentiate that now, it's going to give us, so that's going to be 2 times 3. If you differentiate x cubed, the power will come to the front and then it is reduced by 1. Because if you have y equals ax raised to the power n, and then you find from the first principle, d dx of this expression is going to be an x reduced, power reduced by 1. That's what we are applying in this case. So for the first term, we're going to have 2 times this 3 will come to the front to multiply 2, and then x, 3 reduced by 1, that's going to be this. And then we do the same thing for the next term. It's going to be x raised to the power 1 or just x that. So if you differentiate this, watch out for this, guys. If you watch out, if you differentiate y squared, all right, you're going to have y, and then the derivative of that is going to be dy dx. Okay, the result is equal to 0. So I want you to take note of how y squared was differentiated there. All right, that's like if you handle the case of that, it's going to produce this. So the next thing we're going to do is you have 6x squared minus 14x plus y, the y dx is equal to 0. So we make this the subject, right? Right, we can make this the subject. Or you differentiate, we differentiate again, right? We actually need to differentiate again. So if we want to find the dx of 6x squared minus 14x plus y, then we have dx of this is equal to 0. Now, if you take the second derivative, you have 12x. Then we have minus 14. Then we have, you differentiate this. All right, you differentiate this, we keep this one constant, and then we in turn differentiate that. So what's that's going to be is, this is multiplying that. So if you differentiate this, we're going to have dy dx, then we keep dy dx constant, all plus, then we now differentiate this again. That's going to give us, we have the squared dx, then we keep this one constant, y. The result is equal to m0. Please, you have to watch it very well because it's very interesting. So we now have 2x minus 14. This times this, that's going to give us the y squared. Sorry, that's going to give us all plus the squared y, the x squared. Then we have the squared y. All right. Sorry, we have dx, then yd. All right. Y dy dx is equal to 0. Okay, since we are to find this, we have to find a way of making the squared y, the x squared, the subject of the formula. This is very interesting. Making it the subject, we transfer all the other things to the other side. All right, what that will look like is, we say therefore our the squared y, the x squared equals, if I take this to the other side, I have minus 12x, I have plus 14. Okay, so minus y, I have the y, the x. All right, look at the way it has turned out to be. Okay, so at this point, this becomes the required solution that we were asked to do. Since the squared y, the x squared, equals minus 12x plus 14 minus y, the y dx, right? For x equals 1, y equals minus 1, and the y, the x equals 0. We substitute all of these values into the expression there. So what we have is, that is our the squared y, the x squared equals, we have minus 12, right? Minus 12 into 1, or times 1, plus 14 into minus 1, okay, times 0. The result is minus 12 plus 14, and that gives us a positive value 2. Wow, I hope you did enjoy yourself in the course of solving this problem. All right, expect our subsequent high degree problem solving in this particular aspect of mathematics. I hope you enjoyed yourself. So if you did, please go ahead and click on the notification button. I want you to share this video with friends and families and neighbors. Also, try to give us a thumb up and pass a comment if we are truly reaching out to you, so that you'll encourage us to do more. The best is yet to come.